sklearnmetricspairwisedistancesargmin. Description: this function calculates the indices of the closest points in a set of data points to a given set of query points. It uses the specified distance metric to compute the distances between each query point and all data points and then returns the indices of the closest data points for each query point. Inputs: X a 2D array representing the data points, where each row corresponds to a data point. Y a 2D array representing the query points, where each row corresponds to a query point. Outputs: argmin a 1D array containing the indices of the closest data points for each query point. Steps: for each query point in Y, the function calculates the distances between the query point and all data points in X using the specified distance metric. The function then finds the index of the data point with the smallest distance to the query point. This process is repeated for all query points in Y. Metrics: the function does not directly calculate any metrics, as its main purpose is to find the indices of the closest points. However, the chosen distance metric can be considered a metric of similarity between the query points and data points. Visualization plots: scatter plot visualizing the data points and query points, with lines connecting each query point to its closest data point. Heat map showing the distances between all pairs of query points and data points, highlighting the minimum distances for each query point. Fine-tune parameters: metric: the distance metric used to calculate distances between query points and data points. Common options include Euclidean, Manhattan, and cosine. Axis: the axis along which to compute the distances. One means to compute distances between the rows of X and the rows of Y. Uncertainty methods: the function does not provide any uncertainty measures. However, the choice of distance metric and the distribution of the data points can influence the robustness of the results. Challenges and fixes: Challenge 1: high dimensionality of the data can lead to computational inefficiency. Sample use case that resulted in Challenge 1: a dataset with thousands of features may take a long time to process. Fixes to Challenge 1: consider using dimensionality reduction techniques like PCA before computing distances. Challenge 2: the choice of distance metric can significantly influence the results. Sample use case that resulted in Challenge 2: using Euclidean distance for text data might not be optimal as it doesn't account for semantic similarities. Fixes to Challenge 2: carefully select the distance metric based on the nature of the data and the desired similarity measure.